Hello everyone, I'm Bindu Shriji, pursuing my degree in Electronics and Instrumentation Engineering. I'm currently done with my IoT internship with the Ematex and have learned about the embedded systems and the IoT applications. I'm really excited to explore how technology connects devices to make our life smarter. And the project is based on the home automation solution. Introduction to C. So C is an procedural oriented programming, and also the C is a middle level language which acts as a bridge between the low level and the high level language and can control both hardware and the user logical structures. In number system, the C it is used to represent numbers using a different symbols, digits and base. Types of number systems in C: decimal with the base 10 and the digit uses 0 to 9, and binary with the base 2 and the digit uses 0 and 1, octal base 8 and digit is 0 to 7, hexadecimal base 16, digit uses 0 to 9 and 8 to F. Some of the basic data types in C are int, char, float and double. Int which is used to store a whole numbers with no decimal. Char used to store a single character. Float used to store the decimal numbers with less precision. Double used to store the decimal number with a higher precision. Modifiers. The modifiers that change the size of the type range of a data type. And some of the modifiers are signed, unsigned, short and long. Sign which allows only both negative and positive values. Unsigned allows only a positive values. Short it is reduces the size of an integer, usually 2 bytes. Long increases the size of an integer or a double. Range of a signed int type can so assigned type can be calculated like minus 2 to the power of n minus into plus 2 to the power of n minus 1 minus 1. Range of unsigned type. It is from 0 to plus 2 to the power of n minus 1. Relational operators they are used to compare between two values or an expression. Some are like equal to, not equal to, greater than, and less than or equal to, less than or equal to. And also some of the data types use format specifier for the input and the output to print input and output. Input for int we use percentage of p and float percentage of f and char for percentage of c, string percentage of s. And some statements like nested if, switch case and the jump statements. Nested if statements means if statement inside another if statements. It is used when you need to check multiple conditions one after another. Switch case statements. The switch case is used when you have multiple options for one variable. It is easier to read than many if else statements. Jump statements. They are used to transfer control from one part of a program to another. They help in changing the normal flow of execution in a program. And in jump, we have break and a continue. Break used inside a switch case and loops and brings control out of loops and switch case. Continue, what is only used in the loop and it can skip only a particular iteration. Logical operator. The logical operator is the logical and a logical or and a logical not. In logical and operator also we has two condition and we get one output. In logical and we have a condition 1 and condition 2. If both the condition are false we get the output as true, and if either one is false and another one is true we get the false statement. For logical OR, we have the two conditions that is and with one output. If the two conditions are false, we get the false. But if any either is one or true condition, we get the output in true. Logical not. Logical not is that the condition is true, we get the output as false. If condition is false, we'll get the output as true. In bitwise operators, bitwise and in and also we have two conditions like condition 1 and 2 and then output. In that, if we have both cases of 1 and 1 only, we'll get the output of remaining. If any of the either condition is 0, we get output as 0. And in OR also, if any of the condition is 1, we'll get the output as 1. But if both the values conditions are 0, we'll get the condition output as 0. And bitwise XOR, in bitwise XOR, if any of the condition is either 1 or 0, in condition 1 or 2, we'll get the output as 1. In bitwise complement, if the condition 1 is 1 and the output is 0, and if the condition is 0, we'll get the output as 1. And then bitwise shift, left shift, and bitwise right shift. Array. Array, it is a collection of elements of the same data type stored in continuous memory location. Function. A function is a block of code that performs a specific task and can be reused. Like how do we write a function is that we give a written data type and a function name, and in that we give a data type like argument 1 and 2. Then like to call a function also, we give a function name, and with that argument, how many arguments we want, we'll give like argument 1, 2, 3 and up to argument n. Then string. A string is a collection of characters ending with a null character. Passed by value, changes made inside the function don't affect the original variable. Passed by reference, changes made inside the function affect the original variable. Pointer. A pointer is a variable that stores the address of another variable. Storage classes, they define the scope, lifetime, the memory location of variables. Global variable, declared outside all functions and can be used anywhere in the program. Local variable, declared inside the function or a block and accessible only within that function. Storage classes have like auto, static, register and extend. Auto, it is used inside a function. Static till program ends and register fast access CPU register. Extend till the program ends. The introduction to C++. It is an object-oriented programming, and in C++ the object which is the real world entity. Every object has a state or the property, and the behavior is also an action. A class is a user-defined data type that groups data and functions together in one unit. Class is like a blueprint and an object is a real instance of a class. Members can have a different access specifiers, public, accessible everywhere, and private, accessible only inside the class, and protected, accessible in a derived classes. So constructor, used to initialize the object and automatically called when object is created. Destructor, delete dynamic memory location and automatically called when object comes out of the scope. Encapsulation, binding data members and member function together into a single entity. Abstraction, it means hiding the complex details of important features of an object. Inheritance, it means one class or the child class can use the properties of functions of another class. Reusability of the code and also creating a hierarchy between a classes. Internet of Things. So IoT. IoT means connecting everyday physical devices to the internet so they send, receive and share data automatically. So here sensors and actuators are actually the input, and the collectors which actually collect the signals or the data from the sensors and actuators and use the communication. In communication they use like switches, wireless devices to interconnect, and then the cloud computing or the data process happens in which analysis, storage and data processing happens also, and then that will be represented or in the presentation or in a client devices. So home automation. In home automation, we are using the Arduino Uno, that is in Pixin Lab, and also to write a code, we are using Arduino IDE, and then Blink application Blink IoT app we are using on mobile to create a widgets and control using it from a mobile. The project requirements is garden lights control, temperature control system, water tank inlet, outlet valve control, user interference, blink application. So garden lights control, we have given used ADR. ADR is a light dependent resistor that changes its resistance based on the amount of light falling on it. And the temperature control system heater and cooler is are mentioned, and in which heater if it exceeds more than 35 degree, the heater should automatically off, and also we have to control it, the awning of widgets in a mobile to fix in that. And next is water tank inlet and outlet valve control. Uh, to display the volume of water on a CLCD, also to display the temperature on our CLCD, and even in water also we display the volume of water inlet and outlet of the in CLCD. If the water level is going below 2000, the automatically the inlet valve should get off. And the user interference is the blink application. In blink application is that the blink cloud we actually create an account, and then in that we actually create a template. In template we create on new devices, and we name the devices there, and then in that we actually created data streams. In data streams we create a virtual pen for that. After creating a virtual pen, then in the mobile we install the Blink app, and then they also we need to get all the requirements which have been done in the PC. After that we'll get the data streams, and then we'll choose the buttons, and the buttons are set in the mobile. That is the Blink IoT app mobile. Arduino Uno. In Arduino Uno, here we can see that which has analog pins, that A0, A1, A2, A3, A4, A5, and also which has a power supply of 5 volt, and also it can be connected to ground also. And then next is it has a digital pins, some D0 to D13, and some are with the pulse width modulation. What is pulse width modulation? Is a method to control the amount of power given to device by turning it on and off very quickly. And also D0, D1 are the in and out UART of the in and out. UART D0 is UART of in, D0 D1 is UART of in, D0 is UART of out. And also we can see that in Arduino the reset is also there. As we had said that we use Arduino IDE software tools. So for that we need to know the things in which to interface or give a code. That is somehow like void setup. This function runs only when the Arduino starts to starts or resets. We use it to set up things like pin types, serial communication, etc. And while loop after setups runs once the loop, functions run repeatedly forever. Pin mode, in pin mode we give pin and the mode pin, like for example we give the pin number which in which we are connecting like 3 or 2, whatever the pin give, and the mode which is an output or an input for a given pin. Then digital write is also same, not the same, like we give the pin number but we give the value used to turn on and off of a digital pin. Digital read also we give just a pin because it need to read the value from an input. Analog read pin reads analog signals values between 0 to 1023 from pins like A0 to A5. Analog write pin value sends an analog like pulse width modulation signal to a pin. Delay, we use delay to pause the program for a certain time in a millisecond. Serial begin baud rate start serial communication between Arduino and your computer. Also, the most common speeds is 9600 bits per second. Serial.println data prints information like numbers or text to the serial monitor. That's it. And in serial.write, it sends the raw data bytes. So this is just an code for a garden lights company. Here as I said, the input we have given the LDR, that is the light dependent resistance. Uh, that changes its resistance based on the amount of light falling on it. And here we have defined that one, and also we have defined the LED at the pin number 3, and pin number 3 we have given the LED as an output only. Pin number 3 it is an output, and the light intensity. And here the duty we have given, that is the duty, it's term used when working with pulse width modulation, means how long the signal stays on compared to total time of one cycle. Pulse width modulation is a method to control the amount of power given to a device by turning it on and off very quickly, and we use mostly in controlling LED brightness and adjusting motor speed or control the servo meter and regulating the power in a circuit. Here we have also sent the input value in analog read, that is the LDR input, and this is the logic we have used for to complete one cycle. Then we have given the analog write, then delay. Then temperature control. For temperature control, here we are using the liquid crystal this to I2C.h, the library, because that we need to print the temperature on the CLCD. So we are using the liquid crystal. So we are including that library and also y.h, and in that we are giving that CLCD with the memory location of that, and then the number of rows and the columns. And in a void setup, the LED is initialized, and then it initialized also the backlight and clear and home. And also the cursor is set where it need to start, that is from 0 to 0, the first row and the first column, and then it prints the temperature. Also we have given here the in void loop we have given that the read value from a pin so that we'll get the temperature value, and this is the logic we used. And in CLCD we the ASCII character are displayed on that, so we use a temperature is equal to string and then temperature and then converting number into a string. So to display it on LCD, we are giving the LCD dot set cursor and then 0, 1. Then LCD dot print temperature. Whatever the temperature we get, we need to print it. Next, in water level control also we are using the liquid crystal, as we need to display the water level or the volume of water in a tank. So we are using in CLCD, so we are using the liquid crystal library in this also, and also we use a inlet valve, enable, disable, outlet valve, and a volume. And then here also we are use LCD is initialized, and then LCD is backlight, and then clear and home, and again to print for that to display it on a screen we use a set cursor, and then we print a volume. And in loop we actually give the logic and what and all should be the enable or the disable for the given requirements. And also in main.h we have given the defined the numbers like V1 for temperature gauge V1, cooler weapon, virtual pens. These are all actually the virtual pens we have given, and here we have defined it one is on as one and off as zero. And cooler weapon as V2, heater weapon as V0, water wall gauge as V3, and inlet weapon as V4, and outlet weapon as V5, blink terminal in V6. So now let's see the project simulation. So this is actually the code. Here actually define the Blink template ID and the template name and the authentication token. Uh, when we have created the account and when we create a template, we all get these details. After that, well, we have to save those data and then we have to put it in a code to operate to so that we can connect using from a mobile and our device gets connected. Also, we are using the Ethernet shield for the connection. And here the cooler weapons we have is parameter as initialized for the cooler, and then we have set the cursor when it is off and when it is off not. These are the conditions we have given, and then for inlet and outlet valve also. After the code, then we actually save we save it and then we compile and then we go to sketch, then we do export compiled binary. Done compiling. After that, let me open the Plexin lab, and then I go to a file, then in file I load the text file. In module spare parts, and the permission to display. Now I'll also take the skill remove file. I will connect it. So also so I will also share the screen that. And here these are the button widgets I have created on my Blink IoT app and mobile. So here, as per the project requirement, they have uh, specified that whatever uh, the gauge in the temperature displayed, even in LCD also it should be displayed. Yeah, and even the volume of the tank is also displayed here. So now, the first requirement that they ask if the water inlet, if the water is below 2000, then automatically the inlet valve should on. Now let's see that. Um, in the let now the automatically the inlet valve flow is on. As soon as it turned below 2000, the inlet flow is on. Now I'm hold off the outlet. Then that is let it off. If I leave outlet off below if it go to 1000, automatically the inlet will be on. Inlet flow is on. Now, now let's see for the heater. In heater they have given if the heater is if heater temperature is let's get more than 35 degrees, then it should automatically heater get should off. Then it is on. Now the automatically the heater is off. When you reach 35, the heater is automatically off. Now I will turn on the cooler. If I turn on the cooler, you can see that the cooler is on. And also here I'm wearing the area and you can see the brightness is varying. You can see the brightness of the LED is varying. The LED brightness is varying. When the control uh, heater, the, the LED area we have control the lights of LED by an area. Now also if I ask the heater, we can control it by using the on and off. Heater is on, heater is turned on, and heater is off, turned off, and also cooler turn on, then cooler off, then cooler is on, and the cooler is off. And here for water level tank controller, so the water level is displaying on LCD. So inlet is on. So now we'll on the outlet. So now we'll on the outlet and the outlet is on, and now I'll hook the outlet. The outlet is off. I'll on the outlet inlet. I'll off the inlet. The inlet is on. And if the water goes below 2000, if the water level is 1000, automatically the inlet is on. These are the project requirements. Also, we can see that also we are able to see what and all in this the page what the number is displaying here in my mobile, also in LCD also it is displaying. Next, conclusion. Conclusion is that we use CLCD which acts like a dashboard displaying four widgets from Blink IoT app like buttons, and also used to control heater, cooler, unit power and outlet ban. Thank you.